of the textbook ESRI Guide to GIS Analysis. This topic is about mapping numerical data, and we'll try to understand the patterns of the numerical data that reflect the relative importance of features and places. Let's first talk about why do we want to map the numerical data or quantitative data. Mapping quantities usually follow the steps that we have already mapped the features and categories. Mapping individual features allows us to see the relative location of features and events. However, if we want to compare between features, among features, certain attributes that are carried in the attributes table can be used to differentiate, especially if you want to select certain features that meet our criteria. And such kind of questions will not be possible without looking at the quantitative attributes of the features. So the mapping quantities take us beyond just location, but more on the understanding the differentiation of locations and features. For example, in this particular slide, we have a map on the left showing the location of business. This is sufficient to understand the relative location of business. However, if our interest is on serving the business by transportation infrastructure, for example, and we need to decide what is a bus route and what will be the relative frequency of buses, and in that case, we want to know the relative concentration of employees who have to travel along the street. So in that case, we would like to know how many employees at each business location. And the map on the right shows that picture very clearly, and that gives you a very good idea, understanding of what kind of transportation needs that we need to build. There are many alternative ways to map quantities. The choice of the methods depend on how well we understand the purpose of mapping quantities. That's why we need to spend time to understand why. And if we know the question that we're going to find out, then deciding on the methods of mapping quantity will be much easier. For example, we can choose to map quantitative attributes of discrete features like points and lines and polygons. Or we can map the aggregate data on areas. For example, we can count the number of people in the census tract and map that out as a numerical quantity into visual variables. On the slides, we see there's 5 maps presented. A map shows the mapping of individual features like a business location, but in this case we add the number of employees into the picture and use a graduated symbol to show the relative value. On the B map, we show there's a map of rivers that shows the attributes by fishing habitats and basically classify each river based on a ranking of the quality of the rivers in relation to fishing habitat. There's a number of classes from excellent to poor. And then map C, each of the parcel has associated land value. Map D also show the number of businesses in discrete points, but we overlay the district on top of the business location so that we can see what are the businesses within which district. And if we do some summary based on those areas, we can associate each area with a quantity representing the number of business. Such kind of data can be mapped out to show and compare between places, between areas, in terms of the number of business per square miles.